here to talk through this Minesweeper puzzle, which uses the even rows and columns constraint. I found it had exactly one simple break-in, which had to do with these two clues, the 2 and the 7, where you know that the 7 will have all but one of the cells used in it, and you can say that 2 of these 3 cells will have mines, the remaining 5 have mines. And up here you get something like this. I guess I can notate it like that. That almost suggests we should be looking down this column to figure out how mines go, but really what we have are too much flexibility in the number of remaining positions around things like that 6. You can even start to decorate around the grid places where you know either or mines will go. The 4s at the bottom have all the spots effectively having this scenario, but you're not going to get any simple placements like that. You might be able to do some bifurcation, make success, but it's pretty challenging. So what really happens is a unique kind of step for this next AHA, and it has to do with thinking of the overall sum of sets of columns. And you can do something like think about this clue, and this clue, and let me kind of draw a box around the territory that they own. And you'll see that these clues do not overlap in the cells that they see, but they cover almost all of these first 3 columns. They actually leave just 3 empty cells uncovered. And they see a total of 14 mines, which, given that each of these columns has an even number, means there's also an even number of mines in these remaining 3 cells, so either 0 or 2. If it were 0, this clue can't be fulfilled, so we know for sure that there are 2 mines in the top cells, the unmarked cells, and there'll be a single mine down here. Say, well, that doesn't give you a whole lot. Well, it doesn't on this side, but because of the clue symmetry, the real break-in for the puzzles in these right 3-most columns, doing the same kind of logic, the same 3 clues in the second rightmost column, add up to 18. That leaves an odd sum left over here. So again, we get to the case where it's 2 or 0 mines in these cells. Has to be 2 to get to a total sum. We have 1 mine up here. We have 1 unused. And to complete the 6, the rest of these cells must all be mines. And it's a tricky break-in, but it goes from several minutes of nothing to quickly some progress. We have a few ways to follow up from these clues. I guess I can start here with the 4. The 4 only has 1 more mine left to go around it. This 5 only has 1 more unused to go around it. So we know that the unused cell and the mine for the 4 overlap here. The other cells on the 5 are mines. The other cells around the 4 are unused. That now means this 2 has to take this mine to get complete. These mines have to come over to the left to finish the 2. Can do something similar with this 3. It only has 1 more mine to go. The 7 only has 1 more empty space to go, so those have to meet in this overlapping area. The remaining cells around the 3 are unused. The remaining cells around the 7 are mines. And a lot of Minesweeper puzzles are really looking at these intersection points of high with low, where you don't have a lot of choices left to make. So a couple different ways to proceed from this spot. I guess one thing we can start to do is sums coming across almost finished rows or almost finished columns. I guess we'll do columns first. We have 4 mines in the center column, 1 empty space. If it were a mine, we'd have an odd number in the overall column, so this constraint of even rows and columns comes in first here, forces the shading around the 4. We have 1, 2, 3, 4, 5, 6 mines in this column, so we can't add the last one there. Instead, it's going to be here. If I just sum up here, I have 9 mines in this column. Need to get to 10. That forces that shading. So that's basically marking off columns is unused, or sorry, is filled. We can do the same thing in some of these rows. This row has 4, 5 mines so far. It needs a 5th. This row up here has 3. It needs 1 more. This notation says it's in one of these cells, but not in both of these cells. We now have potential to actually do some counting around this clue. I think this 3 is going to get an issue with this 5. So right now the 3 has 2 mines remaining. I actually made this into a 2. Anytime you have a clue that's next to another clue and has a difference of 3, what that really means is the remaining cells are unused on one side and the remaining cells must be mined on this other side. So there are 2 in this middle. That then allows an overall count to work out. If instead another mine were down here, you'd have a maximum of 1 mine in these 4 cells and you couldn't get a total of 5 overall. So we can use that kind of counting to do a little bit in this space. What we'll end up seeing is we have another either or choice in this cell. In this row we now have 6 mines accounted for. If we use this cell we would get to 7, so we don't use that cell. Finish out the 3 this way. I'm going to have 1 more mine to go on this 5. We can look at this row which has 5 mines and just get to 6. We can look at the top row which has 3 mines so far, 3 empty spaces, so it's going to take 1 or 3 mines. The 7 clue only has 1 unused left around it, so it's going to be forced to have 3 mines up top. Get a scenario where we're going to have 1 mine in these cells, and the remaining count 4 plus 1 is going to need a 6th mine, and that will force these spots. So we've actually finished most of the top. The last somewhat tricky spot to resolve I found was in this bottom left corner, and it again comes from thinking about collections of clues together. So right now we have 1, 2, 3, 4, 5, 6 mines above this space. This 5 sees 2 more mines in this space because of 3 over here. So of the clues we see above, we have accounted for 8 mines and there's 1 empty cell left. If it were filled, you'd get 9 total mines in these 2 columns collectively. It needs to be an even number in both of the columns, so the sum has to be even as well. The consequence is that we can force the location of the mines around the 4, force these unused cells. This column now needs to take a mine to have the correct count. That leaves only these options for the 4. This is all now forced just from local environment and counts. Getting evens for these columns. We can now look across. We have 4 mines in this row. Need to have that empty. The other 2 mines come down here. This row has 6, so that's going to be unused. To get 3 around this spot, it's going to come in here. This has 5 so far. It can take 1 or 3 to get to an even number, but we talked before around the 7 how you're going to need to take 3. In that case, this has 1, 2, 3, 4. This is going to take 2. I'm not sure exactly where those sit, but the remaining 2 will be here. 1, 2, 3, 4, 5. We need 6. We can mark this off. We can actually see this column is empty. 1, 2, 3 need to be here. And this row already has 6, so that ends up finishing the puzzle. And we can check just the column also has an even number. So it's an end to a pretty interesting week with this variation with the even rows and even columns. The puzzle times will be quite hard or high for this puzzle, in part because it's a pretty unusual step of isolating these little tiny regions to get an even count of those cells. If you run into other ways to break into this puzzle, we'll be happy to have you share in the video, but hopefully this gave you a sense of how to combine the even-odd constraints in these spots, places like looking at the columns, as well as just standard Minesweeper rules, like this case up here when we got an implied 2 next to a 5, and we could use that to quickly fill out the remaining cells on the opposite sides of those clues. We'll have many more Minesweeper puzzles in the future, and we'll see you again soon.